Hello students, today I am going to discuss the Lewis-Dot structure of some important molecule, very important molecule. Most of the students face difficulties in drawing the Lewis-Dot structure. What I am going to discuss today. Today we will discuss, I will discuss O3, NO3 minus, NO2 minus, NO2, NO2 plus, OCN minus, this is cyanate, CNO minus, this is fulminate ion, okay, CNO minus, then SCN minus thiocyanate, N3 minus azide, NO, CNO minus cyanide. Structure. Say I have to draw the Lewis structure of O3, ozone. So what are the rules? So first rule number one, we have to find the central atom. Then we have to count total valence electron, Then we have to count number of lone pair of electrons. Then number of sigma and pi bonds, and at last orbital charge. Okay. Yesterday I have discussed all these things in detail. So please go through yesterday's videos. Then only you will be able to understand today's lecture at ease. So okay, central atom. Yesterday I will just briefly I will tell you. Central atom. See, least electronegative, least number. Central element will be least number. Lowest electronegativity. Hydrogen or fluorine cannot be central element. After that, we will count the total valence electron, including charge. Okay. Then we will count the number of lone pair of electrons. If total valence electron is multiple of 8, then central atom will have no lone pair of atoms. The number of sigma and pi bonds means total number of bonds, and after that sigma and pi bonds. How to calculate the sigma bond? Sigma bond basically total number of atoms minus 1. That will give you the sigma bond. For this case, say how many number of sigma bonds will be there? Sigma bonds, total number of atoms 3. So 3 minus 1 by 2. That means there will be 2 sigma bond in O3. Is there any lone pair of electron? Okay, count total valence electron. 6 multiplied by 3, that will give you 18. What is the formula for lone pair of electron? Lone pair of electron formula is valence electron, total valence electron minus 8 into number of bonds. Number of bonds will be 2 divided by 2. That will give you 1. What else you can do? One thing. You just divide 18 by 8. So 8 2 are 16. 2 2 1 2. So this will be basically sigma bond. This will give you sigma bond, and this is the lone pair. Now what will be the number of pi bonds? In this case, we will use a special formula for total number of bonds. Total number of bonds. Where I like. Okay. Next question. Okay. What will be the total number of bonds? Formula for total number of bonds. Formula for total number of bonds. Total number of bonds equal to say 8 into number of atoms. 8 into total number of atoms minus total valence electron divided by 2. That will give you total number of bonds. This formula is very, very important. From this formula, we can easily calculate number of sigma bonds, number of pi bonds, unpaired electron, whether it will be present or not. So this formula is very important. Okay, so these are the formula. So total number of bonds, this formula we will remember this one. Number of sigma bonds is equal to total number of atoms minus 1. From this formula, if you know the total number of sigma bonds, then from this formula we can calculate pi bonds. I will give you the example, then you will understand. So pi bonds, from this formula we can also calculate the pi bonds. And lone pair of electron you can easily calculate. Lone pair of electron we can easily calculate. If it's multiple of 8, multiple of 8, then no LP on central atom. And if it is not multiple of 8, then we will use a formula. That formula is lone pair is equal to total valence electron minus 8 into number of bonded atoms. Divided by 2. See, don't get confused with this one and this one. This one and this one. This is the total number of atoms. 8 into total number of atoms. And this is 8 multiplied by number of bonded atoms. Okay, these are the rules. Based on these rules, we will draw the Lewis structure at each. Let me first draw the Lewis dot structure of O3. Okay, start with O3. O3. So what we will do? See, there are 3 oxygen atoms. So central atom will be here central atom is oxygen. Done. Total valence electron 3 multiplied by 6, that will give you 18. So total 18 electrons are there. Are there any lone pair of electrons? Okay. Lone pair of electron is equal to total valence electron minus 8 into bonded atom 2 divided by 2. That means there will be one lone pair of electrons. Now, sigma bond. How many numbers of sigma bonds are there? Sigma bonds will be total number of atom 3. So 3 minus 1, that will give you 2. So 2 sigma bonds. So 2 sigma bonds, 1 lone pair of electron. This is of course on central atom. Okay, on central atom. Now pi bonds. In order to calculate the pi bonds, total bonds equal to total number of bonds, means sigma plus pi is equal to 8 into number of atoms. 8 into number of atoms, total number of atoms. So total number of atoms 8 into 3. So 8 into 3 minus 8 into 3 minus total valence electron 18 divided by 2. So that will give you 24 minus 18, 6 divided by 2 is basically 3. So total number of bonds are 3. So how many numbers of pi bonds will be there? Sigma bonds already 2. So pi bonds equal to sigma plus pi equal to 3. So 3 minus 2 is equal to 1. Done. If we have all these informations of O3, now we can draw the Lewis dot structure. See, central atom oxygen. From total valence electron, we calculated the number of lone pair of electrons on central atom, that is 1. Sigma bonds 3 minus total number of atoms minus 1, so 2. Total number of bonds. How many bonds? Central atom will form. That is 8 multiplied by total number of atoms. So 8 multiplied by 3, that will give you 24. 24 minus total valence electron 18 divided by 2. So that will give you 3. So pi bonds are 1. There will be only 1 pi bond. Now let me draw the Lewis dot structure. Lewis structure of O3. Okay. We can write here. O3. So central atom O3, central atom oxygen, it forms 2 sigma 1 pi. Okay, 1 sigma with oxygen, another sigma with another oxygen. Now 1 pi bond, put it anywhere, either here or here, it does not matter, it remains same. Okay, let me put it here. Now what are the informations I need to put it here? Lone pair of electron. How many lone pair of electron on central atom? 1. So lone pair of electron will be 1. The structure is already done. Now at the last step we have to check the formal charge. Is there any formal charge for this oxygen, or this oxygen? Okay, let me check. So in this oxygen, 1, 2, 3, 4. So 2 lone pair of electron. This oxygen forms single bond with central. So it will carry formal charge -1. So formal charge -1, and lone pair of electron 2, 4, 6. This oxygen will have any formal charge? Yes. This oxygen will have formal charge loss. This oxygen will have formal charge loss. How? Okay, let me calculate the formal charge. Formal charge, okay, here I will calculate the formal charge. Let me calculate it here. See, when oxygen form 2 bonds, it won't carry any formal charge. When oxygen form 1 bond, it will carry formal charge -1. And when oxygen will form 3 bonds, it will have formal charge +1. So now let me check whether this oxygen will have formal charge plus. It's right or wrong? Okay. What is the formula for formal charge? Formal charge equal to valence electron. This oxygen has valence electron 6 minus of number of bonds 3, sigma plus pi 1, 2, 3, plus lone pair of electron 1, 2. That means plus. Done. So this oxygen will have formal charge +1. This oxygen will have formal charge -1. How? Okay, let me show you that. Formal charge -1. This oxygen formal charge will have -1. Formal charge for this oxygen 6 minus 1 plus 6. So that will give you -1. So this is the Lewis dot structure of O3. Now there will be one more structure, that is the resonating structure of O3. If we draw the resonating structure, of this O3, it will look like O. Okay, I think better I write some lines. Okay, I'll write it here. Better I'll write it here. Oxygen single bond, CH double bond, plus 2, 2, 4, 6, negative 2, 4. That's all. And this one is the equivalent structure. You can draw any structure, Lewis structure. Now if you count the total number of electrons, 18, just count 2, 4, 6, 8, 10, 12, 14, 16, 18. 6. Like this way, you can draw the Lewis structure of any molecule at ease without facing any difficulties. See, there are some other methods. People for drawing the Lewis structure, people follow other methods also. But for me, this is the best one. Student won't face any difficulties if they follow these simple rules. You need to remember some formula, then only you can draw the Lewis dot structure, any Lewis dot structure. Okay, let me now show you another Lewis dot structure. That is, okay, now I am going to draw the Lewis dot structure of, say, NO3 minus. Follow the Lewis dot structure. So we will count the total valence electron. I will show you step by step. So don't worry. step by step. Okay, total valence electron, total valence electron, total. See, central atom will be the nitrogen. There is no problem at all. Central atom. Total valence electron. Okay, total valence electron 5 plus 3 multiplied by 6 plus 1. That will give you 24. Means this is multiple of 8. So no lone pair of electron on nitrogen, no LP on nitrogen. Done. Next, sigma bonds. Sigma bonds is equal to total number 3 plus 1 4. So 4 minus 1, that will give you, so 3 sigma bonds. Means this central atom will form 3 sigma bond with these 3 oxygens. Now pi bonds. In order to get pi bonds, we'll put a formula that total bonds equal to 8 multiplied by total number of atoms 314. So 4 minus 24 total valence electron divided by 2. So that will give you 32, 24, 8. So 4. This will give you 4. So pi bonds will be pi bond equal to 1. That's all. Done. Everything is done. I have got all the informations of N3 minus. Now based on these informations, I will put Lewis dot structure here. Lewis structure. Dot means Lewis dot structure means we won't put the bond, rather we will put only the electron. That is the difference. That is the difference. If you remove the bond, say this, if you put the bond between A and B, that is Lewis structure. And if you do like this is Lewis dot structure. Now, of course, if there are electrons, lone pair of electrons, you need to put it on A and B. Okay, now let me write the Lewis dot structure NO3 of NO3. So, okay, nitrogen is central. Problem, nitrogen is central. So, nitrogen form 3 sigma bond with 3 oxygen. Okay, 1 oxygen, 2 oxygen. Okay. 3 oxygen. Okay. Now nitrogen form 1 pi bond. 1 pi bond. Okay. Put 1 pi bond here. 1 pi bond here. Structure is already done. NO3 minus. This is the structure. Now we need to check the formal charge. We need to check the formal charge. Okay. This nitrogen will carry formal charge. Last. See, yesterday I have discussed all these things in detail on formal charge. You can go through that video. So nitrogen form actually 4 bonds. So if nitrogen forms 4 bond, then it will carry formal charge plus 1. This oxygen, okay, put the lone pair of electron. So see, this oxygen is happy. 1, 2, 3, 4, 5, 6. It has 6 electron. It fulfills octet. 1, 2, 3, 4, 5, 6, 7, 8 octet. No problem. Okay, this oxygen form 1 bond. It means it will carry formal charge minus 1. So put minus 1 here and 2, 4, 6. Whenever oxygens will have minus formal charge means it will have 7 electrons. So 1, 2, 3, 4, 5, 6 and 1 electron is used for forming this bond. So 7 electrons. And for this also same. So put it here. 2, 4, 6, 10. Now NO3 minus total charge minus, so minus 2 plus 1, that will give you minus. This is the Lewis structure. This is the Lewis structure of NO3 minus. This is the Lewis structure of NO3 minus. Now this pi bond you can put it anywhere. This is resonance, or else you can put it here also. So either here or here or here, it does not matter. It will give you the equivalent structure, 3 equivalent structure of NO3 minus. This is the Lewis dot structure for NO3 minus. Okay, next, how can we draw the Lewis structure of NO2 minus? Okay, let me draw structure of NO2 minus. NO2 minus. Okay, central atom. Sorry. Central atom, nitrogen. Total valence electron. Total valence electron 5 plus 2 6 7 12 plus 1, that is 18. 18 means one lone pair of electron. You just calculate from the formula. So lone pair of electron equal to 1. Sigma 1. Sigma 1's beta. Sigma 1 2 3 3 minus 1. So that is 2. Okay. 5 bonds. Okay, total number of bonds formula 8 multiplied by 3 24. 24 minus 18 divided by 2, so 6 means 3, so 5 bond equal to 1. So done. All the informations we have got it. So NO2 minus, draw the structure of NO2 minus. So nitrogen is central. Nitrogen is central. Form how many sigma bonds? 2 sigma bond. 1 sigma, 1 sigma, 1 pi bond. With any nitrogen oxygen you can put it. So 1 pi bond. Lone pair of electron. 1 lone pair of electron here. Done. Structure is done. Now you just put the lone pair of electron here. 1 2 3 4. 1 2 3 4 5 6, and this oxygen will carry the formal charge minus nitrogen won't have any formal charge. So this is the structure for NO2 minus. I hope you understand. This is the structure for NO2 minus. This structure. Okay. You can put pi bond either here or here, that does not matter. It will give you the same structure. It will give you the same structure. Now, let me draw the Lewis structure of NO2. Now, let me draw the Lewis structure of NO2. Lewis structure of NO2. Lewis structure of NO2. This structure, student face difficulty because it is basically odd electron species, but won't a big issue if you follow the rules. Okay, so first central atom, nitrogen is the central atom, no problem, nitrogen is the central atom. Second, total valence electron. Total valence electron beta 5 plus 6 into 2, that will give you 17. 17. So if it is 17, it is a problem whether there will be a lone pair or one unpaired electron. That I will show you. It won't be a big problem. Number 3, let me first count the sigma bond. Sigma bonds, how many number of sigma bonds beta? Sigma bond 2 3, so 3 minus 1, that will give you 2, so 2 sigma bonds. Now let me put the formula for total number of bonds is equal to beta 8 multiplied by 3, no? 3 minus 17 divided by 2, so that will give you basically 7 divided by 2. 7 divided by 2 means 3 bonds plus 1 unpaired electron. Okay. If you divide it by 2, that will give you 3 bonds, total bonds 3, and 1 unpaired electron. Okay. Now how many number of pi bonds? See, 3 bonds. Out of 3 bonds, 2 sigma bonds are there. So pi bond will be pi bond pi bond is equal to 1. Informations, we have got all the informations. So how can we draw the Lewis structure, beta? We can draw in order to now draw the Lewis structure. So nitrogen is central. Nitrogen is this one. Nitrogen is central. Nitrogen is central. Nitrogen form 2 sigma bond with 2 oxygen. So one oxygen and this is another oxygen. Now one pi bond. One pi bond either with this oxygen or this oxygen. It is not at all issue. So put one pi bond here. So this is the pi bond. So 2 sigma 1 pi. Now unpaired electron, it will be on nitrogen here. So this is the Lewis structure. Now this is beta neutral, no charge. So how can we show that there will be no charge? Okay, if oxygen forms single bond, then that means it will carry a charge that is -1 formal charge. So 2 2, 4 and 6, and this nitrogen, whether it will carry any charge, formal charge or not. Let me check that. See, this will have formal charge -1. It won't have any formal charge. So 1, 2, 3, 4 done. This oxygen is happy. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Okay. How about this one? Nitrogen has any formal charge or not? So let me calculate the formal charge. So formal charge equal to valence electron. So valence electron nitrogen 5. How many bonds? 3. 3. How many lone pair of electron? Only one electron. So plus 1. So that will give you beta 5 minus 4. That is basically plus 1. So this will carry plus 1 formal charge. So this is the Lewis structure. This is the Lewis structure for NO2. You can put pi bond either here or here. That does not matter. So this is the Lewis structure for NO2. Okay. Now let me show the Lewis structure for azide N3 minus. Lewis structure for azide. Okay. Do it by step by step. Central atom nitrogen. Total valence electron 5 3 5 16. Sigma bonds 2. 3 minus 1. Pi bonds. Before we calculate the pi bonds, we have to put the formula for total number of bonds. Beta koto gulo? Okay, sometimes I will use Bengali for my Bengali students, because I have lots of Bengali students. Sometimes they used to tell me that, sir, why don't you speak in Bengali? Because if you don't speak in Bengali, we face lots of difficulties in understanding your lecture. So I'll speak sometimes in Bengali and translate it in English. So don't worry. So kotogulo pi bond are? How many numbers of pi bonds? Okay, put the formula for bonds. 8 multiplied by total atoms 3 minus 16 divided by 2. So 16, 24, 16, that is 4. So 2 pi bonds. So pi bond will be 2. Duto pi bond. The central atom nitrogen, total valence electron 16, sigma bond 2, pi bond 2, total bonds 4 means pi bond 2. Okay, all the informations I am having. I have got all the informations to draw the Lewis structure. Now let me draw the Lewis structure. Okay, is there any लोन पेयर ऑफ इलेक्ट्रॉन और नाइट्रोजन, नाइट्रोजन ऊपर की কোনো लोन पेयर ऑफ इलेक्ट्रॉन আছে नहीं है, there is no lone pair of electron because it is multiple of 8, multiple of 8, so no lone pair of electron. Now let me draw the Lewis structure for azide. What is the Lewis structure? Okay, nitrogen is central atom. Okay, form 2 sigma bond. Okay, 2 sigma with nitrogen. Then what? 2 pi bonds. 2 pi bonds. Put 2 pi bonds here. Anything else? Nothing. Done. Now question is এখানে কেন দুটো পাই বন্ড দিলাম, এখানে একটাও দিতে পারতাম। why we put pi bonds here? We can put pi bond here also, one by one. Okay, we can draw it, no problem. We can draw it in double bonded it in double bond. Done. এইবার ক্যালকুলেট করা যাক যে কোথায় আমার চার্জ আছে, ফর্মাল চার্জ। Now we need to calculate where is the formal charge. So formal charge, it's a very simple. It will carry formal charge, of course, because it forms 4 bonds. Okay, it won't carry any formal charge. See, when nitrogen forms single bond, it will carry -2 formal charge. How? -2 formal charge. You just do like this way. See, you just remember like this way. See, nitrogen like that. So if nitrogen forms 2 bonds, means this bond you just break, so 1 formal charge, this bond you just break 2 formal charge. So when 1 bond will be there will be 2 formal charge on nitrogen. So you just put here -2 means this nitrogen will have electron how many? 1 2 3 4 5 6 7. See, that will give you -2 formal charge. You can calculate that. How you can calculate? So formal charge equal to valence electron -1 plus 6, 2 4 6. So that will give you -2. So this is the Lewis structure for azide. One more structure. Okay, when nitrogen form 2 bonds, see this will have formal charge plus. Okay, formal charge plus, no problem. How about this one? This one will have basically negative -1 formal charge -1. So electron 2 to 4, 1 2 3 4 5 6. That's why -2 4 5 6. We're done. Now if you calculate the total number of electrons, then what will happen? So total number of electron here 16. Let me count that. 2 4 6 8 10 12 14 16. Here 2 4 6 8 10 12 14 16. Done. Now question is which one will be the best or stable structure for these two? Till now, whatever Lewis structure I have drawn, all the Lewis structures were equivalent. After drawing the resonating structure, so there was not at all a problem. You can put any structure or you can show the any Lewis structure. But here it's a problem. So this is the Lewis structure or this is the Lewis structure. See, whenever you will have two things, you have to keep in mind to draw or to get or to know the best one. ফর্মাল চার্জ যত বাড়বে, ফর্মাল চার্জ যত ইনক্রিজ করবে, স্টেবিলিটি ভাই তত কমবে। এটা একটা মিন্স ফর্মাল চার্জ ইনক্রিজেস, স্টেবিলিটি ডিক্রিজেস। এটা একটা আর একটা ওয়ান মোর যে পজিটিভ চার্জ অন ইলেকট্রোনেগেটিভ এলিমেন্ট লেস স্টেবল, negative charge on electronegative element more stable in the same structure. Negative charge on electronegative element more stable. And one more, neutral structure is the most stable. Neutral structure. If you get any neutral structure, that will give you the best one. So out of these two structure, here -2 maximum Fermat charge and here -1. So this I can say the best one or most stable structure out of these. This is the Lewis structure of N3 minus. This is the Lewis structure of N3 minus. Now next proceed with the Lewis structure of which one? N2O. Okay, let me draw the Lewis structure of N2O. Let me draw the Lewis structure of N2O. See, after going through the formula, if you draw the Lewis structure, it will look like, okay, so central atom nitrogen, total valence electron beta 16, lone pair of electron 0, sigma bonds 2 3 minus 1 equal to 2, bonds 8 multiplied by 24 minus 16 divided by 2, so 20 for 4 pi bonds, so 2 sigma 2 pi, that's all. 2 sigma 2 pi. Now let me draw the Lewis structure. It will be the Lewis structure. Okay, nitrogen central. Okay, from 2 sigma 2 pi, 24 16 2, so 3 minus 1 2 sigma 2 pi. Okay, so 2 sigma 2 pi, that will be one structure. So total 4 bonds, 1 2 3 4. One more possibility, we can draw 1 sigma 2 sigma 2 pi. This is the possibility. One more possibility, N triple bonded O N, that's all. These are the three possibilities. Now which one will be the best one out of these three? So okay, let me put the Fermat charge here. Fermat charge here will be plus. Here Fermat charge, no Fermat charge. How many electrons? 1 2 3 4. How many electrons here? Here Fermat charge, okay, minus. How many electron? 2 4. Here Fermat charge positive. Here no Fermat charge. Here Fermat charge minus. So 2 4 6. Is there any Fermat charge for here? Okay, here positive. Oxygen carry positive, so 2. That's all. 2. Here nitrogen minus 2. So 2 4 6. These are the three possibilities. Now which one will be the best structure? See, this one will be ruled out. This is not the best structure. Why this is not the best structure? By এখানে অক্সিজেনের মতো পজিটিভ চার্জ আছে. অক্সিজেন ইজ দ্য ইলেকট্রোনেগেটিভ এলিমেন্ট. ইট ওন্ট লাইক টু হ্যাভ পজিটিভ চার্জ. ঠিক আছে? প্লাস Formal charge also maximum, that is -2. So this structure is not the stable one. Now, out of these two structure, which one will be the best one? See, here nitrogen carry negative. In both the structure, nitrogen has formal charge positive, central nitrogen. Here nitrogen carry negative, here oxygen carry negative. So electronegativity of, see, electronegativity of oxygen is more than electronegativity of nitrogen. So this is the base structure. Okay. So this one is the best one. Which is that one? Plus minus. Okay, fine. Done. So this is the best structure. Like that way you need to draw the Lewis structure. Okay. Now let me show the Lewis structure of fulminate ion. Fulminate ion is the special structure. It's a very special fulminate ion. Why it's a special? Why fulminate ion? Why is the special? Because CNO minus, right? Here nitrogen will be the central atom. Expected that carbon will be the central atom because in case of fulminate, nitrogen is the central atom. So it's a very important structure. Remember this structure. Which structure? Nitrogen here central atom. That is the special one. Nitrogen is the central atom. Nitrogen is the central atom. Now just count the electrons. Nitrogen central element that I have mentioned. Now total number of valence electron you just count. Lone pair of electrons, number of bonds, sigma bonds, pi bonds. If you count that one, and after that you will get a structure. I am directly going to draw that structure. That structure is basically C double bonded N double bonded O. This is the structure. You just go by yourself, you will get this structure. C double bonded N double bonded O. Okay. If I get one structure, then from that I can do the two other structures. See here 2 sigma 2 pi. 2 sigma 2 pi. Okay. Nitrogen will have formal charge. Okay. Before that, let me draw some other possibilities. So okay. So 2 sigma 2 pi means you can draw C triple bonded in single bonded oxygen. This is one possibility. One more possibility, C single bonded in triple bonded oxygen. One more possibility. So these three possibilities are there. Out of these three possibilities, I need to find the best one. Which one will be the best one? Okay. In order to know that, let me put the formal charge. How can we put the formal charge? Okay, put the formal charge. Here formal charge will be positive, no problem. Nitrogen formal charge 4 bonds, positive, no problem. Here nitrogen positive charge, formal, no problem. Oxygen, here formal charge, sir, oxygen positive, say CNO minus, so 1, 2, here it will carry formal charge -3. See, when carbon form one bond, it will carry the formal charge -3. How? Because carbon form 4 bonds, right? So 1, 2, 3, 4. So 1 bond, 3 bonds, 1 negative, 2 bonds, 2 negative, 1 bond, 3 negative. So 3 formal charge. 2, 4, 6. Then only 7 electron. 2, 4, 6, 1, 7, done. Carbon 1 means here formal charge negative. So 2, 2. That's all. Done. No problem. Here oxygen form single bond. So negative. No problem. Negative. So 2, 4, 6. Total 6 electrons. How about this case? In this case, this is minus 2. So 2, 4, 5, 6. Okay, no problem. This is 2, 4. These are the distributions of electrons. So like that way, electron I have distributed. Now if you count the total electrons, no? So total electrons, how many total electrons are there? Okay, let me count that. So 4 plus 7 plus, sorry. Okay, no problem. 4 plus 5 plus 6 plus 1. Total 16 electron. 4, nitrogen 5, oxygen 6 plus 1. So 16 electron. Now any structure you can take and you can count the total electron. See 2, 4, 6, 8, 10, 12, 14, 16. Here 2, 4, 6, 8, 10, 12, 14, 16. Here 2, 4, 6, 8, 10, 12, 14. Now out of this structure, see, this carry maximum formal charge minus 3. So this is not the best one. This is not the best one. How about this one and this one? See, here carbon carry minus 2. Max formal charge, more the formal charge, stability will be less. So this is also not the stable one. So this is the best one. So there is the structure. This is the base structure for fulminator. This is the base structure for fulminator. Like that way, whatever formula I have shown you, if you follow the rules, you can draw any structure without facing any difficulties. Believe me, without facing any difficulties. Cyanide. Cyanide. What will be the Lewis structure of cyanide? What is cyanide? Cyanide is OCN minus. OCN minus. We just count the valence electron, total valence electron, sigma bond, pi bond, and after that you will get a structure. I will draw that. O C triple bond N. 2 sigma, 2 pi, central atom carbon, no lone pair of electron, we can easily calculate from here. 6 plus 4 plus 6 plus 4 plus 5 plus 1, further 16. One more possibility. What is the possibility? One more possibility. Okay. Okay. C double bonded N. Double bonded N. That's all. But one more. You can draw. You can draw anything. These are the structure. Now we need to find the best one. How can we do that? In order to know that, first we will put the formal charge. See, carbon form 4 bonds. Carbon is happy with that. So carbon needs or has no formal charge. It is happy with 4 bonds. Fulfilled octet 1, 2, 3, 4 means 8. Fulfill octet 2, 4, 6, 8. Fulfill octet 2, 4, 6, 8. Very happy. No problem. Oxygen, okay, minus 1, 2, 3, 4, 5, 6. Then only 7 minus. So oxygen is happy here. Nitrogen, of course, formal. No formal charge, just one pair of electrons. That's all. Count how many electrons? 16. 2, 4, 6, 8, 10, 12, 14, 16. Done. Here 2, 4, 6, 8, 10, 12. Okay. Nitrogen form 2 bonds. So one formal charge. Now count 2, 4, 6, 8, 10, 12, 14, 16. Done. How about this one? So oxygen positive. So only 2 electrons. One lone pair. Carbon is very happy. Nitrogen -2. So -2 means 2, 4, 6. 2, 4, 6. Now count. 2, 4, 6, 8, 10, 12, 14, 16. Here 2, 4, 6, 8, 10, 12, 14, 16. Done. Now from this structure, you need to find the best one. Which one is the best one? See, if you look at the structure, you can see. See, first of all, oxygen is not happy with formal charge +1 because oxygen is very high electronegative element. So remove this one. It is not the best one. Out of this one and this one, see here, what is the difference? Here nitrogen carry formal charge. Means nitrogen carry charge -1. Here oxygen carry charge -1. See, electronegativity. Okay, let's use this one. Electronegativity of oxygen is more than electronegativity of carbon. So this is the best structure. So I can say that this is the best structure. Best structure for cyanate. Base structure for cyanate. Done. Base structure for cyanate. This is the base structure for base structure of cyanate. Okay. Now let me show you the Lewis structure for thiocyanate. Thiocyanate. What will be the Lewis structure for thiocyanate? Thiocyanate means HCl minus. Okay. Carbon form, if you follow my formula, then you will get the structure like this. C is the center, so C double bonded N, double bonded S, one possibility. C triple bonded N, single bonded S, another possibility. C triple bonded S, single bonded N. These are the possibilities. Okay, put nitrogen is happy with 4 bonds, no formal charge. Oxygen like sulfur, like oxygen, sulfur form 2 bonds, happy 2, 4. Okay, I'll here negative, so 2, 4. Here only 2. Here oxygen like sulfur, oxygen, so -1, so 2, 4, 6, 7. That's what -1. Here sulfur positive, so only give 2. Here no. Here oxygen, nitrogen minus 2, 4, 6. So if nitrogen form 3 bonds, that is, so if it form 1 bond, then -1. If it forms 2 bonds, if it form 2 bonds, then -1. If it form 1 bond, then -2. That's what -2. So overall charge is -1. So plus -2, -1, minus here. Now out of this one and this one, which one will be the best one? Can you guess which one will be the best one? Can you guess? Very simple. Here formal charge is maximum, -2, and sulfur won't be happy with positive. Formal charge is maximum of nitrogen, so remove that one. This is not the best one. This one and this one, see, nitrogen has negative charge on it. Here sulfur has negative charge on it. The electronegativity of nitrogen is more than electronegativity of sulfur. So nitrogen like to have formal charge rather than sulfur. So which one will be the best one? This one will be the best. This is the best Lewis structure. Okay. This is the thiazide magnet. This is the best Lewis structure for thiazide magnet. Now you can calculate. See, central atom has no carbon, central carbon, no lone pair, because total valence electron, if you count, no, total valence electron, if you count, no, then how much? 6 plus 4 plus 5 plus 1, that will give you 16. So I think I have shown you most of the interesting and difficult Lewis structure, especially today's lecture. Whatever the structures I have shown, please practice it, go through it. Please practice it. It's not so easy. You need just by practice couple of times. Then you will be master in drawing Lewis structure. Are there any structure left? Okay, let me show you some other structure. Like, you see, in class 12, you need to draw the oxides of nitrogen. Oxides of nitrogen. You have. Okay, one more structure. I think better I will draw it. This is NO. Nitric oxide. NO. What will be the Lewis structure? See, this is simple structure. Total electron, how many many? 6 plus 5 equal to 11. Bonds koto? Bonds koto? How many bonds? Okay. How many bonds are there? Okay. Bonds by 8 into 2, 16 minus 11 divided by 2. Sir, 5 divided by 2 means 2 bonds plus 1 unpaired electron. 2 bonds plus 1 unpaired electron. That's all. So if you draw that one, let me show you. So this is the Lewis structure. N double bonded O. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Okay. Nitrogen is 5. 1, 2, 3, 4, 5. Oxygen 6. 1, 2, 3, 4, 5, 6. Oxygen is happy. Nitrogen did not fulfill octet. There will be one more possibility. Why don't we put unpaired electron on oxygen instead of nitrogen? Okay. Put here you just put unpaired electron, and here you just put like 2, 4, 2, 4, 6, 8, 9, 11, 2, 3, 5, 7, 9, 11. Okay. So here we put unpaired electron on oxygen. Here we put unpaired electron on nitrogen. Now, if you calculate the formal charge, what will be the formal charge? Let me calculate the formal charge. Here, is there any formal charge? Okay, formal charge equal to 5 minus 2 bond plus 3, so 0. So no formal charge. Here, no, oxygen is happy with 2 bonds, so no formal charge. 6 minus 2 plus 4 equal to 0, so no formal charge. Here, nitrogen formal charge equal to 5 minus 4 plus 1, 2, 3, 4. 4 plus 2 bonds, 2. So minus 1. Oxygen 6 minus 1, 2, 2 bonds plus 1, 2, 3, 3. So 5, so plus 1. So in the structure, nitrogen carry formal charge minus 1 and oxygen carry formal charge plus 1. What I told, that any structure, neutral structure is the best one compared to the charged one. Charged species is less stable compared to the uncharged one, or charged less species. So it has no formal charge. Say overall minus 1 plus 1, 0. So NO has no charge. So which one will be the best one out of this one or this one? This one will be the best one. So if you want to draw the Lewis structure, so this is the best Lewis structure for NO. This is the best Lewis structure for NO. Okay. Now, see. Now let me show you some other structure like N2O3, N2O3, N2O4, N2O4, N2O5. See, in class 12, in group 15, you have to draw the oxides of nitrogen. I will give you the simple trick to draw the oxides, different oxides of nitrogen. How to draw? Okay. See, in order to draw that, first we will draw here NO, Lewis structure of NO. Lewis structure of NO I have just now shown, which are 2, 4, 1, done. Okay, what will be the Lewis structure of NO2? NO2, let me draw the Lewis structure of NO2. N double bonded O, single bonded, this is minus, unpaired electron, this will plus. I think this is the Lewis structure for NO2. You can count, you can calculate. So it will have formal charge, Sure, 2, 4, 6. Okay, 2, 4, 6, 7. Okay, 2, 4, 6, 7, no problem. 2, 4, 2, 4, 6. Okay, this will have formal charge because 5 minus 1, 2, 3. 3 plus 1 electron, so 2 plus 1, so formal charge plus 1, no problem. So this is the structure for NO2, this is the structure for NO. Now how can we draw the N2O3 or N2O4 or N2O5? How can we draw that one? I'll show you a simple trick. Easily you can draw that. Okay. Here one unpaired electron is there. Here one unpaired electron. Here one unpaired electron. This one unpaired electron and one unpaired electron. This unpaired electron and this unpaired electron will form the bonds. Okay. Let me first show you N2O3. I can think like N2O3 equal to NO2 plus NO. So write N okay NO, okay, N double bonded O 2 here and one unpaired electron here. NO2, okay, N unpaired electron here, double bonded O and single bonded. Okay, done. Now you just connect this bond. This unpaired electron and this unpaired electron form a single one. This is the structure for N2O3. Simple, very simple. This is the structure for N2O3. N2O3, you just think like that way. N2O3 is basically NO2 plus NO. Then you will get the structure for N2O3. Now see, you can, whatever formula I told you, you just put that formula. From that formula you can count the total bonds. See, total bonds, what formula I have given you? 8 multiplied by total atoms. 1, 2, 3, 4, 5. So 5 minus valence electron. Total valence electron. Okay, how many valence electron? 2 5s, 10, 3 6. 3 multiplied by 6, 18, 80. So 28 divided by 2. So 40 minus 18, 12 divided by 2. So 6. See, total 6 bonds. So you just count whether there will be 6 bonds are present here or not. See, 1, 1, 2, 3, 4, 5, 6. So this is the correct structure. Formula is also correct. This is the correct structure for N2O3. Now, if you need to draw N2O4, you just combine NO2 plus NO2. How? Okay, N2O4. Sorry. Okay, I will move to next. N2O4, N2O4. So you just combine NO2 plus NO2. So it will give you, see, N double bonded O, this one, double bonded O, single bonded, here dot, okay, N double bonded O, single bonded oxygen, okay, no problem, unpaired electron here. Now you just put the bond between this one and this one. So 1, 2, 3, 4. So nitrogen will carry formal charge. Now put formal charge. This is positive, here negative, here negative. So total, it is chargeless. This is the N2O4. So total bonds, if you calculate the total bonds, okay, let me show you the total bonds. Total bonds formula. Okay, how many numbers of elements are there? N2O4 4 and 2 6. 6 multiplied by 8 minus total 5 10 4 6 4 6 24 34 divided by 2. So 48 minus 23 is 34 divided by 2 plus 7. 7. Now count the 7 more. 1, 2, 3, 4, 5, 6, 7. Okay. Now you can put the electron here 2, 4, 2, 4, 6. Here you will put 2, 4, 6. Here we will put 2, 4. That's all done. 7 more count. 1, 2, 3, 4, 5, 6, 7. N2O4 done. Now one more structure. If you have to draw the N2O5, then how will you draw the N2O5? It's very simple. You just think that N2O5 is basically N2O4 plus oxygen. So you just put in between oxygen, in between nitrogen, you just put oxygen. Okay, I'll put it. I'll do it here for you. So double bonded, single bonded, double bonded, single bonded. Okay, 2, 4, negative charge. Okay, oxygen 2, 4, nitrogen 1, 2, 3, 4. So positive, and nitrogen positive. So no charge. No charge. So if you want to count the bonds, how can we do that? Bonds, how can we do that? So, okay, bonds. How many numbers of bond will be there? So bonds, say 5 to 7. So 7 multiplied by 8, 50. 2 multiplied by 5 plus 5 multiplied by 6. These are 40. This will give you 40. Sorry. So 40, 56. That means 16 means 8. 8 bonds. 1, 2, 3, 4, 5, 6, 7, 8. That's all done. 8 bonds. So if you follow this formula, if you follow these rules, whatever I mentioned, you can draw any Lewis structure. Any Lewis structure. Okay. Please go through the yesterday's video. Yesterday I have shown the Lewis structure. See, I have divided. Now let me tell you briefly. I have divided category 1. Category 1 means Lewis structure for 1, and category 2 Lewis structure 2. Here I have shown PO4 minus 3, SO4 minus 2, SO2, SO3, PCl3, PCl5 BO3 minus CO2 whatever SnF3 BCl3 BF3 BCl3 like that. CO3 minus 2 CO3 minus 2. Okay, these are the structure yesterday I have shown you, and for that the formula is same for both these two category. Only number of bonds, that formula will be different for this one and this one. Well sir, how can we understand which formula is will be used for this one and which one will be used for this one? Okay, today what I discussed, NO2 NO2 minus NO3 minus NO N2O4 N2O5 thiocyanate HCl minus OCl minus cyanate CNO fulminate azide N3 N2O NO okay. O3 anything left? I think most of them. Okay, NO2 plus anything else? No, fine. Say for this one, these are the mostly nitrogen containing molecule. Mostly nitrogen containing molecule. For nitrogen containing molecule, you just apply this formula. That formula where I will write. Okay, you can first check this one, then I will write the formula. Okay, for nitrogen containing molecule, you will write the formula like this. I will write it here. Okay, I will write it here, beta. I will write it here. Only one formula will be different, that is bonds. Here bonds will be 8 into total number of atoms minus total valence electron divided by 2. This is the formula. That will give you sigma plus pi. This formula will be used for category 2. And in this case, we will use the number of bonds. That formula will be electron minus lone pair. That will give you the. So this formula, this is the difference in formula. Other things remain same. Means central atom, you have to follow the rule. Whatever the rule you will be followed here, same. Okay, lone pair. Here if it is multiple of 8, then there is no lone pair of electron. If it is multiple of 8, then also no lone pair of electron. Sigma bonds means total number of atoms minus 1. That will give you sigma bond. Okay, pi bond. While calculating pi bonds, you have to formula for this category. You have to formula bonds equal to valence electron minus lone pair, and for this case, you have to apply this formula. Done. I think this is all about Lewis structure. Please go through it. If you have any difficulties, please inform me. PDF for this one, Lewis structure. I will give you the best PDF for Lewis structure. You just write me if you want PDF. So thank you so much.